Hello, class. So we'll finish section 2.2 today. So as I mentioned, we're in skipped section 1 in chapter 2. In the previous videos, we saw what a separable differential equation is. It's basically a differential equation where you can write it in this form, right? dy dx equals some expression involving only y's and constants times some expression involving only x and constants. And again, the reason why that is useful is because if you have a separable differential equation, you can do what we did here in the previous video, where you divide h of y on both sides, and then you just integrate each side. So that was the method. Whenever you have a separable differential equation, you can do that. The thing to note is that I did mention that you want to be able to do this. So write everything involving y on one side and everything involving x on the other only by dividing. If you try to move things around by subtracting, then that won't work with this algorithm. Now, I also mentioned that it's not always obvious that a differential equation is separable. Sometimes you have to rewrite it to make it clear, okay, this is separable. I have some expression only involving y's and constants times some expression only involving x and constants. And this example that we did before was a good example of this. Okay. Now let's do one more example. Okay. So let's solve the differential equation dy dx equals x times y squared minus 2. And again, remember that solve is equivalent to asking, find the general solution. So this differential equation is already given as separable, right? Because we have some expression only involving x and constants times some expression only involving y or constants. Let me call it h of y. Okay, so this is separable. So what do? We just divide h of y on both sides and integrate. So divide both sides by y, integrate. So by h of y, sorry, not y. So y squared minus 2 x equals integral. So we're left only with x on the other side. Again, this left-hand side, dy dx times dx just becomes dy. We're left with dy over y squared minus 2 equals. Here we can just integrate directly, x squared divided by 2 plus some constant. So now how do we integrate 1 over y squared minus 2 with respect to y? Well, you could try u substitution, but that really won't work and doesn't really make much sense because I mentioned before, you want to do a u substitution if you can find something that looks like a function and its derivative. If we were to let u be equal to y squared minus 2, its derivative has y's in it. Right? And there's no other thing involving y in this expression. Right? So the u substitution doesn't work. You can do integration by parts. I don't think that's going to work either. So another technique that I mentioned that you have to be thinking about is partial fractions. Okay? So I won't go over how the whole process works. You can always just Google partial fractions. I think the first link is Purple Math, and they tell you what the algorithm is. But basically, you want to rewrite this as a product, as a sum of two fractions. Right? You want to write this as a over something, which we don't know what it is yet, plus b over something. What is that something going to be? Well, if the goal is, can you factor this? So the denominators are usually the factors of whatever expression you're trying to rewrite. In this case, we can rewrite y squared minus 2 as y minus square root of 2, y plus square root of 2, if my algebra is correct. Yeah. Okay. So we want to write this somehow as a over y minus square root of 2 plus b over y plus square root of 2. Oops. Right, so that's the goal. So we want both of these things to be equal. So, and actually let me give myself some more space here. Like this. We want these things to be equal. So let's just make them equal. Let's multiply this. Oh, maybe not useful. Let's multiply this right-hand side out and set it equal to the left-hand side. Or add it out, sorry, add it. Okay, so we're adding, we need a common denominator. The common denominator can always just be the product of each denominator here. So if we rewrite the right-hand side, So A, we need to multiply top and bottom the first fraction by y plus square root of 2. That's the factor that's missing. So it becomes A, y plus square root of 2. Now for the other part, well, we have y plus square root of 2 on the bottom. We're missing y minus square root of 2. So multiply top and bottom by y minus square root of 2. So we get this. And of course, the common denominator is y minus square root of 2 times y plus square root of 2. Right, so it's just adding fractions, right? Something you learned in college algebra. Now, if you remember, the only way two fractions are equal is if you can somehow, if they have the same denominator, is if the numerators are equal. So really the expression or equation we have to solve here is 1 equals a times y plus square root of 2 plus b times y minus square root of 2. Right? All of that equals 1. So 1 equals this. So what constants a and b satisfy this equation? So there's a couple ways you can do this. The easiest way for me is this equation has to be true for all values of y. So we can choose specific values of y that simplify this. For example, let me go down here. So if we let y be square root of 2, then this equation becomes y equals a times, well, y square root of 2, so y square root of 2 plus square root of 2 plus b times square root of 2 minus square root of 2. So this part goes to 0, and this part goes to 2 square root of 2. So we have 1 equals 2 square root of 2 times a. Divide both sides by 2 square root of 2. A equals 1 over 2 square root of 2. We can do something similar to solve for b. Just plug in values for y that are going to simplify things. In this case, let me use another color. I guess purple. If we let y be equal to negative square root of 2, and plug it into this equation, we get y equals a minus square root of 2 plus square root of 2 plus b times minus square root of 2 minus square root of 2. This goes to 0. This goes to 2 square root of minus 2 square root of 2. So this equation simplifies to minus 2 square root of 2 times b. Divide both sides by b, by negative 2 square root of 2. So what do we get? Negative 1 over 2 square root of 2 equals b. So now we found a and b. Now we know how to write 1 over 1 divided by y squared minus 2 as, this sum. Oops. It's this sum of fractions. So let's plug that into this integral. So, we have the integral of dy. Actually, let me write the dy later. So 1 over y squared minus 2. We saw that's the same as 1 over 2 square root of 2, right? That was our a, divided by y plus square root of 2 minus 1 over 2 square root of 2 y minus square root of 2, right? That just comes from a equals 1 over 2 root 2, b equals negative 1 over 2 root 2, and then plug them into this equation here. dy, this equals x squared over 2 plus d. Now you can integrate, right? Because you can integrate each of these ones separately. Just do a u substitution, like as we've done before. So I'm not gonna finish this problem. You can finish it as an exercise. I just wanted to remind you that there is this technique called partial fractions that you can use. And again, the whole idea of partial fractions is write an expression that you can factor out the denominator. In this case, you can factor out the denominator of 1 divided by y squared minus 2. You can factor it as y minus root 2, y plus root 2. So goal of partial fractions is to write that fraction as the sum of two fractions, with denominators being each factor, and the numerators being coefficients to be determined. Now, this is the last thing for this section, as I mentioned. Basically, is a differential equation separable? If yes, divide both sides by h of y and integrate. The integration might get a little bit messy, like in this case, where you can have to do partial fractions, but you should be able to do it.